Hi. In this video, we'll try to see what are the different mathematical operators present in C. Now see, printf and scanf, both the functions are only available on the computer version of C. But these mathematical operators are present in every version of C, purposefully embedded C that we are more interested into. So these are the same mathematical operator that you will use anywhere with C language. So this asterisk symbol is for multiplication. Just give me a minute. This bullets is causing a little bit of distraction. So let me remove those bullets. Yep. So this asterisk symbol, it is called as asterisk. Commonly we also call it star, but asterisk is the name. It's for multiplication. The forward slash is used for division. Percent symbol is used to create a modulus operation or a modulus operator or remainder of a division. I will show you what is it. And you know about addition, we already did it, and the subtraction. So I will omit addition and subtraction for now, and we'll just try to understand these operators first. Now let us try to do some programs. Since our focus is to understand C from operator style embedded perspective, it is also important now to understand about the data type very well before you do any such operation. Why I am telling you this thing is, see, we said char is 8-bit data type and int is 16-bit data type. Many people think that, or many of the typical C trainers will tell you that you cannot use char to hold the numbers. Let us prove them wrong first. So instead of int ABC, let's make it char ABC. Okay. Many, and I'm telling you, many C trainers or professional trainers may tell that this is a wrong program, but this is definitely not a wrong program. So we have a char variable, we have written values into it, and let's print it. %d, I will use %d because I have to print the int value is equal to %d, comma a, comma b, comma c. Look at it. It's not at all mandatory or compulsory that you have to have int in order to perform the addition. Now this is this was a real mistake. Okay, I'm coming from Python background, so I'm forgetting printf. Now see, 45 plus 10 is equal to 55. Do we get any errors? Do we get any logical errors or any kind of errors for that matter? No. Why? Because char can very well be used to store numbers. Then why they say you use only int variable in C? Reason is very simple. Now that's what I'm going to explain you. Now, for that sake, I will open an Excel sheet, okay? Now, when I say char, it is typically an 8-bit variable. Now, what do you mean by 8-bit variable? Now, 8-bit variable means what? You can have a number which is in binary, minimum this, correct? 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. And at the max, this can be 1, 1, 1, 1, 1, 1, 1, 1. Okay. Now let's say what is this 8, 0 in binary means. So this is binary representation, right? Let's see what is the decimal representation of it over here. So let's do this entire line highlighted to understand, and let's do this entire line highlighted to understand. So an 8-bit variable can hold only 8 zeros up to 8 ones. Open the calculator in your machine. You have a programmer's area over there, or programmer's calculator over there. Choose binary format. Just give 8 zeros, or it is always 0. So 8 0, nothing but 0 and decimal. If you give 8 ones in binary, then it is 255 in decimal. Okay. So a char can hold 0 to 255 numbers. Now 0 to 255 is a very small range to work with. Okay, you can understand you can't do much operation within this range. That's the reason why we don't use char and we prefer using int. Now let us try something with this program where we'll try to say 145 or let's say 100 plus 27, just a number addition, and let's see. 100 plus 27 is 127. 100 plus 28, let's try this. 100 plus 28 is minus 128. Now what is minus number? Where did it came from? Here you have to understand again a very important point, and that is the data types can be categorized as signed character or signed integer or unsigned character or unsigned integer. I repeat, signed char or unsigned char, signed integer or unsigned integer. When you don't write anything here, when you just write char, it is always assumed as signed char. Now the problem with signed char is the most significant one bit is used as sign. So out of 8 bit, if we get only this first bit is used as a sign character and all of the others are used only as numbers. So when you are using this signed variable or signed character, then you can see your range is limited from 0 to 255 to minus 128 to 127. When this number becomes 1, it is treated as negative number. Let me show you this. What we did, 100 plus 27. So look at the binary version of it. It is 7 zeros. It means with a 7-bit number, 127 is the highest number that is possible over there. As soon as you add 1 to it, let's see, plus 1. Then it becomes the 7th number 1 or 7th bit 1 and rest all zeros. This is 128. In C programming, if your variable has been characterized as a signed variable, then this is treated as minus 128. And whatever number you give in front of it will come minus 128 plus 1, means minus 127 plus 1 minus 126. Let me show you how. It may sound a little bit complex for you, but if you re-watch this video multiple number of times, you will get it. So if I run this, it is minus 128. Now let us do one more thing. Let's print 1 into it. Now minus 128 plus 1, minus 127, plus 10, minus 118, plus 20, minus 108, plus 28, minus 100. Are you getting it? So this is how the signed numbers are represented in C programming or C compiler. Particularly when dealing with embedded systems, we are not using the negative numbers much often, at least when you are getting started with it. So it is a very, 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 very important habit to cultivate, that when you declare your variable, declare it as unsigned char, whatever you want it. So this is 100 plus 28 plus 20, for example. Let's see the addition here. 148. Cool. Now let's make it 200 plus 50. It should be 250. Sorry. Build and run. 250. Let's say B it's 55. Then it is 255. The result is 255. All good up to this? Now the problem will be when I make it 256. Why it's a problem? Because even if your variable is unsigned char, an unsigned char is what? It will be 1111, 1111, means a whole 0 to 255 range is given to you. But now your result is going to be 256, and an 8-bit variable cannot hold this number because 256 means adding one more digit to it. So in decimal, if I write 256, look at it. So it is 1 is added and then rest 8 zeros. A char will not be able to store such number. So instead it will simply store zeros, the remaining 8 zeros. 0. Getting it? Now, if this thing is for char, what is it for int? Exactly opposite, okay? Exactly opposite. So, not opposite, but exactly the same way. The only thing with int is, assigned int will have how much numbers? Let's see. It's minus 32768 to plus 32767. And an unsigned int will have 0 to 65535. This is the range of 16-bit numbers. When working with embedded systems, we always prefer using unsigned int, and in typical situation when we have very less RAM available in the microcontroller memory, we also use unsigned char. Let's say I am reading some value which I know that is not going to go above 100. So it's better to use unsigned char in such situation. Let's try it. So unsigned int ABC. Let's keep 65,534. Let's keep B as 1. Let's print it. The result is 65535. That is the last limit. If I do plus 1 into it, 65536. Okay, let's see how it appears on the compiler. So on embedded compilers, int will always be 16-bit wide. Here it may be 32-bit number. Let's try this on, because compilers will act differently. Yes, compilers will act differently on different computers. So on a PC, int is not just 16-bit, but it is a 32-bit variable. But since we are trying to understand things from embedded perspective, understand that on embedded systems, the int variable is having 16-bit value. If you go to a higher version of microcontroller like 32-bit ARM controllers, then you will have to look into the data sheet of those. Most probably, the 32-bit compilers will also implement int as 32-bit value, and the same limitations will come for it. I hope you have understood this data type very well in this video. If you haven't, just go back again, try some experiments and try to get it fully. Then we'll start with the mathematical operators in the next video. Thank you for watching this video.